Welcome to today's lesson on quadratic functions and applications. Quadratic functions are functions in which you have an x squared. So if you will look on this document, you will see here is your x being squared, and every function on this page will have an x squared in it. Now it starts by referring to this form y equaling, and this is referred to as the vertex form. And numbers 1, 2, and 3 are in the vertex form, or they are very close. Something you must be aware of with the vertex form of an equation is the minus sign between the x and h and the plus sign before the k. So number 1, you have the minus sign and the plus sign, which makes it pretty simple to identify the value of h and k. On number 1, your h would be 3 and your k would be 2. Your a is the coefficient, and this would be assumed to be a -1. Number 2 is a little more challenging because you do not have the correct signs, being minus in front of the 3 or a plus in front of this 5. The signs are opposite of what they need to be like the vertex form. So we can rewrite this by making this an x minus and making this a -3. So it's x minus a -3 and then plus a -5, adding the opposite. So at this point we have rewritten it so you do have the minus and the plus as defined in the vertex form of the formula above, and now you could identify the h value as -3 and the k value as a -5. Once again, your a would be your coefficient, which is 4. In topic 2, they ask us to find this value of -b/2a. Notice that in these equations there are no parentheses, nothing is factored. So when nothing is factored, your a is in front of your x squared, your b is in front of x, and your c is your number on the end. So if we look at number 6, the first number, the first coefficient, would be a -1/3, which would be our a value. The second coefficient is the coefficient of x, which would be our b value, and the 1 would be c, although we don't need it for this question. We are asked to come up with the value of -b/2a. So I repeat the negative, and then b is 6 over 2 times an a value of -1/3. This equals a -6 over a -2/3. Well, a negative divided by a negative is a positive, so we could refer to this as 6 divided now by a +2/3. And division by a fraction is the same as multiplying times the reciprocal, resulting in 9. So 9 is our -b/2a. As we scroll down, again it's referring to -b/2a, but they also want me to evaluate the given equation at -b/2a. Let's look at number 10. A would be equal to -2, and b, the coefficient of x, would be 12. Therefore, -b/2a would be negative from the formula. My b value is 12. 2 times a is 2 times -2. This would result in a -12 over -4, or my b value would equal, or not my b value, excuse me, my -b/2a is 3. So that's the first part of the question. Then it says evaluate this equation at that number 3. So we're going to equate this to x. 3 is x. So if I have an x value of 3, which is really my -b/2a, then my y value would be a -2 times that 3 squared, plus 12 times 3, plus 4. Negative 2 times 9 is negative 18. And as I continue to evaluate this, I get a value of 22. This is a y value. So an x value of 3, which is my negative b over 2a value, and a y value of 22. We're going to find in the near future that when you put this as an ordered pair, 3, 22, this is going to be referred to as a point on the line, specifically the vertex. Numbers 12 through 15 are asking to find the value of n on the end of this expression so that this expression could then be factored as a perfect square. Well, a perfect square would be a binomial to the power of 2. So we have to find out what the number would need to be for n so that trinomial could be written as a perfect square. This process is quite interesting. We want to refer to the middle coefficient, the 10, and the process is to take 1/2 of that middle coefficient, 1/2 of 10, which is 5. This number, I then square it, resulting in a 25. This 25 is what you want this n to be, so this can be written as a perfect square. In other words, y squared plus 10y plus 25, my new n value, can be factored as y plus 5 perfectly squared. The 5 comes from my parentheses, taking 1/2 of the coefficient of that middle term. Now it asks me to solve an equation, a quadratic equation, by using the square root property. Look at number 16. It says x squared equals 25. The square root property tells me I can take the square root of each side, remembering to put the plus minus in front of the square root, to solve for x. Now I have two answers. One is that x is positive 5, and the other is an x value of negative 5. Number 19 is very similar, but rather than just having x squared, I have this 2x plus 1 squared. However, the algebraic process would be very similar in that I would take the square root, putting the plus minus sign in front of the square root, resulting in 2x plus 1 equaling a plus minus 4. This results in two equations. One is 2x plus 1 equaling the positive 4, and the other is the 2x plus 1 equaling the negative 4. So now I solve these two equations. I subtract 1 from each side and then divide by 2. And again, I subtract 1 from each side and divide by the 2. The solving process results in two solutions, which I'm putting in squares. Looking at number 20, it is very similar to 19. However, our difficulty is that the plus 2 needs to be moved to the right side of the equation before applying the square root. So I must begin by subtracting the 2 off of each side of this equation, so my perfect square is isolated on the left side. Now when I apply the square root, the right side is the plus minus square root of 81, which is plus minus 9. So this branches into two equations, one being x minus 5 equaling 9, and the other x minus 5 equaling negative 9. When I add 5 to each side of these equations, I result in my two solutions of 14 and negative 4. My next topic involves solving a quadratic equation. Number 22 is a perfectly written quadratic equation in which you have an x squared term and you are equaling 0. when you have your quadratic equation written with your x squared term on the left and the whole equation equaling 0, you can apply the quadratic formula, which is x equaling negative b plus minus the square root of b squared minus 4ac over 2a. There is a melody that goes with this formula, which is x equals negative b plus minus the square root of b squared minus 4ac all over 2a. That melody, if you recall, is from Pop Goes the Weasel. It's a little bit embarrassing to sing that, but you can practice it maybe when you're by yourself in your closet at home. So let's look at 24. It is not set up to apply the quadratic formula because it is not set equal to 0. So let's move the x squared to the left side, which would make it positive, and it would also cause this to equal 0. Now it is set up as a quadratic equation prepared to apply the quadratic formula. The a value is the coefficient of the x squared, which would be 1. The b is the coefficient of x, which is negative 2. And the c is the number on the end, which is also a negative 2 in this quadratic equation. Therefore, applying the quadratic formula, x will equal negative of b, which is another negative value, plus minus the square root of b squared, which would be negative 2 squared, which is 4, minus 4 times a times c, all over 2 times a. This is now a positive 2 plus minus the square root of 4 plus 8, which is 12, all over 2, which is 2 plus minus 2 square root of 3 over 2. Recall that the square root of 12 is the same as the square root of 4 times 3, and the 4 is a perfect square root that comes out as a 2 in the front. I can reduce this by factoring a 2 out of the top and then reducing the 2 over 2, making it equivalent to 1. So I have two x values. One of the x values is 1 plus the square root of 3, and the other x value is 1 minus the square root of 3. These would be referred to as your solutions to this quadratic equation, applying the quadratic formula. I'm going to close the video here and restart a new video for the connection to college algebra.